here we are group 13. My name is Marie Christ. We bring number 22302361. Then we are going to talk about the different strategies of teaching the electrodynamic concept. But our group we are going to focus on the concept which is Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction stated that when we change magnetic flux, it induces electromotive force. Mathematically, it states that as I have said, changing magnetic flux induces electromotive force. This negative side indicates that magnetic flux and induced electromotive force goes in opposite directions. Yes?
Yes.
Then, as you see, this concept seems somehow abstract. But our group, we are going to share with you different strategies you can use while teaching this concept so that your students can get different ideas and try to relate this concept to your life situations. Then we will come to continue.
Good morning, class.
Good morning.
My name is Inductio. We've registration number 22345 I'm going to talk about some misconceptions that arise during teaching Faraday's law of electromagnetic induction. The first one is Faraday's law is only about moving magnet. Here, students think electromotive force is induced when magnetic move near the coil, but it is not true because when electromagnetic force can be induced by changing magnetic flux. The second one is Faraday's law applies only to coils. Here, students think that when electromagnetic induction occurs only on coil, but Faraday's law applies to any closed conducting path, not coil. Thanks. Let me welcome another continue.
Thank you. My name is Faraday, with registration number 2230086664. So, I'm going to show you how you can demonstrate this Faraday's law in the laboratory, or we can use virtual online lab. In dynamics, and then again in statistics. Faraday's law tells us in dynamics all carry off magnetic fields are equal to so this means that if you change electric field, you get magnetic field, and again if you get magnetic field, you get electric field. That implies this formula, or it's generated, it induced electric current. Usually, in a simple circuit, this is bulb Then this is wire. And this is safe. Is only way you can get current because the role of battery is to produce current. But by Faraday's law, there is another way you can. You have a question?
Yes. About the battery is it
So this is negative. I have said that there is another way you can induce the current by Faraday. Let's we explore it together. Let's explore it together how can we induce current without battery. So it's by Faraday's law. We have a parameter tools such as coil and then bulb in order to get if we have a current. Finally, we have a magnet to produce magnetic field. How it's work? By Faraday's law, it cannot work without relative movement. Relative movement between the coil and a magnet. Without relative movement, there is no induced current. Okay? Okay. Then I fix the coil, then I move our bar magnet. Then what you see? Then at the bulb is on. We get light. So means that if we move a magnet to the coil, then we directly produce a current which is going to be induced current. This is how Faraday's work by online lab. For yourself, you can access this laboratory at the FET. Akadomo FED, Akadomo Gov, or you search FET. Is where you have access more assimilation used in physics. Thank you, Rem. I invite another group mate to continue.
Thank you. My name is Mariam Tuksenge, with leg number 2230 26 77 and 0. So I'm continuing with another strategy which calls hands-on activity. So in this strategy, in order to use it, when we are going to use hands-on activity, when we are going to explain Faraday's law of electromagnetic induction, we use what you call lab experiments. These lab experiments will help you to perform the Faraday laws. So in lab experiments, teacher will prepare experiment protocol, like material. Student will use the steps. Student will follow and the objective of that experiment. So in materials, students we are going to use in order to perform lab experiments. They will use magnets and the coil. So the step teacher will the student will remove magnet in and out of that coin in order to show that induced current. So, thank you. It is my presentation.
Thank you. I'm here by name of Negawima Emmanuel, leg number 223004474. Now I'm here to talk about another teaching strategy called based equal learning. POE strategy. Here where P stands for predict, O for observe, and E for explain. Now, when you are going to teach this Faraday's law of electromagnetic induction, you can use this basic equation and use this POE strategy. Now, here in predict, when you are going to predict, you take the runners like put the experiment. You can take the runners before you are going to do the experiment. You take like this magnet, this one, and you put inside here, and you ask the runners, what do you think is going to happen? Now the runners starts to explain. I mean to predict. Others start saying that those coins will return around. Others say the right. Others say what. They give you the ideas. Now for there you read them with those answers, and now you perform the experiment. While the runners are observing now, you plug in the magnet and they observe the results. Now, after they observing the results, you start asking them now explain. From your predictions and your observation, compare those answers and now explain what you have got. Are you getting? Yes. Really? Okay, now I think in sciences this can be good while participating in your experiments by using this POE. Now, this is my presentation. I can welcome another member.
Good morning once again.
Good morning.
My name is Marat Jamberi with leg number 355. I'm going to continue with another strategy which called the assessment and reflection. This strategy on assessment, we have formative assessment occurs during or immediately after teaching. In this strategy of assessment, formative assessment, teacher can use conceptual question or calculation-based question. On a conceptual question, teacher, they check whether student understanding a concept, not calculation. On calculation-based, teacher checks where about the concept. On the summary about the assessment and the reflection, they check student understanding about topic and helping them to think deep about what they learn. Thank you. This end of our presentation. If anyone has a question, may ask.
Thank you.
Thank you.